side. That's what you need. So you need the positive side.
Yeah, only the negative side. Why, Professor?
Because you can only find a
Because it's
positive.
symmetrical.
It's symmetrical.
I still never figured that out.
One side, take it out, turn it over, and ask it to print the other side. I do like all right, question 3. If you look at question let me clarify something. I might ask you again, okay, in case you get lost. So here I asked, what's the probability of losing 5%? What's the probability of making 10% or more? What is the corresponding return if I say what's the probability of losing money in a day? What's the probability of losing money in a given year? Okay, how do we calculate that?
Anything below 0?
So what's the probability of losing money? Say, in this case, this is okay here. So what's the probability of losing money in a given year? So how do we calculate a z-score for that? Right. So losing money. When do you lose money? Return is below 0. Okay. Just plug in a return 0 here. Okay. Plug in a return 0 here, and then look for that z-score.
So anything below.
It's not going to be 50% because the mean is positive. 0 is below the mean. Okay. You have a probability associated with that.
It's gonna be negative.
Yeah.
Yeah.
So if you replace this with 0, this is about yes, this score is about minus 0.5.
Yeah, minus 0.476.
Right. So the probability gotta be less than 0. This is minus
0.03.
about 32%, like 32%. But effectively, 32% chance you lose money in a year. That's more or less like 1 out of every 3 years. You're gonna lose money. Okay? If you invest in the stock market. What about in a day?
38%.
What's the chance of losing money in a day?
Daily.
How do you calculate that?
275 times 21.
Oh, 0.0.
This is a day. What's the chance of losing money in a day?
48%.
The day is right here. It's asking you for this side. To the left side is 0. You find out z-score for 0.
Negative 0.0.
0 minus
Times 21. Oh, it's per day.
Minus 0.03.
What about gaining?
48%.
yeah. So you get 48.8% of losing money. So I'm going to show you in a day, it's almost like a flip. Okay? Half the time, 51% of the time you make money, 49% chance of losing money. But you do it consistently. Over time, they start to accumulate. Okay? All this 0, 1, 2% edge in a daily basis. Over time, in a year, and you only lose money 1 out of 3 years. So here, you lose money 48, 49 out of 100 days. It's not very exciting. Okay? So, but if you do this over time, then the probability of losing money starts to get smaller and smaller. Okay? Here you money, you can see the chance of making money or losing, the chance of making money is the chance of not losing money, right? So you have 49% of losing, then you have 51% of making. So the z-score, you can see this z-score for making or versus losing money is the same as the ratio. It's like a minus the ratio calculated in part A, mean standard deviation ratio. Okay? In this case, 0 minus something, just that it's just minus the mean return. Denominator you have standard deviation. So this ratio is actually quite important. The mean standard deviation ratio effectively tells you a lot about the chance of making or losing money in a different horizon. This ratio gets bigger and bigger. Mean standard deviation ratio gets bigger and bigger as the time period you're looking at grows longer, which makes the probability of losing money less and less likely. Okay? This is almost like this. You flip a coin with someone, you win 51% of the time. If you do it once, it's almost like winning and losing almost equally likely. But if you do this 100 times, what's the chance after 100 times play, you still end up losing money? If you have tiny edge over a lot of repeated plays, you start accumulating your edge. Okay? The chance of losing gets smaller. All right. You know, with all my hard work every day, I only make money probably 3 out of 5 days. If I make money in a good year, some years I have good luck, I can make money 2 out of 3 days. But that's just a very good year. Okay? Most of the time it's like 3 out of 5. It's a miserable life. Okay? Effectively, Tuesday, Thursday is good, Wednesday is good, then Monday, Friday gotta be bad, right? On average. Okay? You need to have the psychological strength to get over all the bad days. Not to mention some days are pretty bad. And you can have I think 2 days before the final resolution of this debt limit, fight. 2 days before that, 2 days, and let's start to fight this and that. I think I lost about $120,000. I made back probably 150. But still, that 2 days is stressful, right? Still, by the end of the day, I sort of know it's not going to be the end of the world. But along the way towards the destination, that's not the end of the world. It feels like the end of the world. Okay? That's how politicians know what they do. Just make you feel miserable. But all this chaos they created also created opportunities that you can know if you have believed it. Okay? I'm trying to show you the egg is small. If you can do 3 out of 5, that's very good. Okay? Good enough. Good enough to get to BMW 5. All right. So question 3. Now we try to learn about the accuracy of this 3.75 estimate. Okay. So remember, the 3.75, you never really know what's the average daily return, what's the true mean of stock market return. All you know is you estimate from historical data. So in this case, the question gives you $5,040 days, 20 years. So this meal is calculated as the average of 5,040 returns. Okay. So part A is asking you, what is the how accurate is this? What is 95% and 99% confidence interval? Okay, let me explain that in a second. First, I want to know what's the standard deviation of the mean estimate. Okay, this mean estimate is not like the weekly return, weekly mean, or annual mean. Remember, the weekly return is the sum of daily returns. This is still a daily return, but it's average over 5,000 days. And this is your estimate. If you just pull out 1 day, what's the average? This is your estimate, 3.75. the question is asking you, how accurate is that, okay? So we need to assign a standard deviation for the average of the 5,000 variables, okay? So how is that related to the standard deviation of 1 day standard deviation? So 1 day is 125, which is to say, R1, R2, each one of them has standard deviation 125, okay? So what is standard deviation for the average then? So standard deviation for many, many days is just 1 day divided by the number of days. So here is 50, 40. Okay? 1 day is 125. This is 50, 40 is like 70 squared is 4,900. It's like 71.
70.992.
71. Okay? So when you have 1 day is 125, you have 5,000 plus days, you can shrink it by a factor of 71. This gives you 1.76.
07.
Okay? So what is 1.76 is saying, you know, your estimation is 3.75, but that number, although it's measured as average over 5,000 days, it's still not very accurate, okay? Because each day is so noisy, even you, after having so many days, there's still a lot of potential variation in that number. Okay, the standard deviation is 1.76, okay? If you want to put, typically, when you do a survey, you have a mean, then you plus minus 2 standard deviation. That's sort of a range you feel comfortable, okay? But if you put this plus minus 2 standard deviation, that's going to cover a very wide range, okay? So the lower bound, let's say, mean minus 2 times standard deviation. That's 76, 52. So this is 23. Okay. So you put 2 standard deviation error bands. The lower bound is as low as 23 basis points. That's I'm sorry, 0.23 basis point. This is 3. This is 3.52. Okay. So the lower bound, 2 standard deviation lower bound, is 0.23 basis point. So usually we call this one number the sample mean. We call this the point estimate. If you just ask me, give me one number, what's your best estimate? 3.75. Okay.